Hi, today I'm going to tell you how to load data into CSynth and start manipulating it. So first thing to do, go to the csynth.org webpage and then go to try CSynth, and then there's an example or two. You go down to login or register, click on register or login. You can also sign in if you've already pre-registered, and you should be presented with some previous projects that you've done. If you're new, you won't get any project at all. So the first thing you want to do is create a new project. Now the project we're going to do is going to be based around a paper by Udall-RNL. I'm going to click try C. This was single allele chromatin interactions identify regulatory hubs and dynamic compartmentalized domains and nature genetics. And the nice thing about that is what they do, they've got very high resolution data to about 4 KB per fragment using a Capture-C protocol. And you can see one of the figures in the paper, they show how the erythroid self-interacted domain is visible on the heat map versus the embryonic stem cell, which is also visible on the heat map below. So what we've done is taken that data and we've slightly changed the format, though CSynth does accept normalized matrix formats. We call it a contacts format. So let's just load that in. And the contacts format looks like this, where you basically got a chromosome start, a chromosome stop, and then some sort of interaction frequency. Now we currently only handle one chromosome at a time, so that's worth bearing in mind when you're loading in new data. But there are plans to increase this in the future. So if we call it something nice, such as a bit nicer called Freud, and then submit that. Then we'll add another contacts file. This is the embryonic stem cell contact data. Call that stem cell. This is all mouse data, by the way. We could submit this, and then you've loaded 2 data sets up. And what we can do now, we can launch CSynth, and it's just showing you how it's loading. And you'll have 2 data. This is the erythroid data, then you have the stem cell, embryonic stem cell data. Now you can see the shapes a bit different. Now, I'm not going to go into detail about the simulations here, but what I am going to do, I'm going to load the settings files that we've generated to make these structures more visible. And this is it's a text file which you can save from any CSynth session. Once you've found the modeling that you're happy with, you can then save it as a .settings file. It'll save it as a .settings file from the interface, and then you can load this back in. So to any other project. So when you're happy with it. So what you'll see now, you'll see we've got the original launch CSynth button, which has got the default settings, and then we've got the new launch CSynth button, which has the modeling erythroid settings. And if I load that, you'll be able to see this is similar to the paper now. So we can see this structure here and compare it, say, to this is the erythroid, this is the stem cell, and you can see the heat map here is changing, and we can look at different points on the heat map where that is on the heat map to the 3D structure, or vice versa. You can see where that lays on the particular heat map. And that's what I'm showing you in this video. Do another video showing you how to overlay your beds and big data, part 2. So thank you for listening.